we are starting to talk about domain. And domain is really important because domain is, well, the only domain I've ever told you about is the x value. So I give you an ordered pair, a list of numbers, or I give you a table of values and I say all the x's are domain. But domain also, and it's one of the definitions I gave you yesterday, domain also tells us if I scan a pencil or my arm, if I'm at the board, or a ruler or whatever, if I look along the x-axis, where will my graph appear? Where will it hit? And you're like, appear, hit, what? So I'm going to do this graph. The domain is the x value in an ordered pair. Yes, we know that. However, on a graph, the domain is where the graph appears when you slide along the x-axis. So I'm going to look and I'm going to say, well, this line actually goes off of the graph. And that line is going to go forever to the left. Isn't this line eventually going to hit negative infinity? Because I can't count that high or low. I can't count that low. I could say, yeah, I'm going to count negative to negative a million. Ugh. But then I have to count to negative a billion. And then I'm going to count to negative trillion. And then I'm going to go to quadrillion. What? No way. I'm not going to count that. So in math, we just say that's negative infinity. It's so low we can't count that. Do you see how this arrow is going forever to the left? The other direction, this arrow goes forever to the right. So when I scan let's scan the ruler. When I scan the ruler along, I'm going to have negative infinity way over here. Negative, 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 negative. Oh, I finally went positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, infinity. All the way to the right. Forever to the right. So I'm going to say that this domain, the x values here, is two things. I'm going to say it's all real numbers. And you need to know both things I'm going to say. There's a special R that's in math books. It's like an R with a line down it. That symbol means all real numbers. And then I have another thing to say to you. The domain is also negative infinity, left. On the left, where does my graph go? It goes all the way to negative infinity. And then to the right, where does my graph go? Oh, my graph goes all the way to positive infinity. Can you guys practice your infinity symbols? So, my domain is going to go all the way to the left, and then as I scan, all the way to the right. I'm going to say negative infinity to positive infinity. So, this domain. So, let's look up here at my notation. Less than, greater than, and then an open circle and a parentheses. This is supposed to be a closed circle right here. Can you bubble in that black dot? You guys, on the computer, I could not find a closed circle anywhere. So I had to make it open, and you can bubble it in. So when I talk about less than or greater than, a line is less than or greater than, or an open circle on an inequality, or parentheses when I have to graph it and use this interval notation. If it's a less than or equal to or greater than or equal to, I would use a closed circle if I wrote an inequality, and I would use a bracket to talk about something that's included. Parentheses is excluded. So, we're going to talk more about this notation as we go along. When I use the symbols for infinity, I always need to use a parentheses. Now, this graph right here, I've got a closed circle. So, I'm going to go scan left to right with my ruler or my pencil or something. So, this domain starts at, what is this line that it starts at? Negative 6, do you see that? And this negative 6 is a closed circle. The closed circle means a bracket. So I'm going to say from left, negative 6 with a bracket around it. And then I'm going to say, where is it going? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, forever towards where does it go when it goes to the right? Positive, forever and ever and ever. I can't count that high. What's it called when it goes forever and I can't count that high? Infinity. So I'm going to put from the left, it only starts at negative 6. But as I scan to the right, it's going to end up going to infinity, and infinity always has a parentheses around it. You also might see somebody say that the domain, which is x, is greater than or equal to negative 6. That's another way to write it. But at Troy, we like interval notation. But you need to know that there is another notation that exists. So I don't want to leave that out. Okay, so that's on a graph. When I look at a graph, I scan from left to right. I need to be careful to either use parentheses or a bracket, depending on what the graph looks like. Okay, another rule for domain. The domain for a function, an equation, has only one rule. The denominator cannot equal 0. Set the denominator equal to 0 to find out the restricted number. So I cannot have a denominator that equals 0. Well, number 5 doesn't even have a denominator. So it's asking me what numbers can I use for x? What numbers can I use for x? Well, negative 3 times x plus 5. What could I plug in, you guys? What could I put there? Yeah. Any number, all real numbers. Negative infinity to positive infinity. Or I could say all real numbers with that special r. All right, what about this denominator? The denominator cannot equal 0. So in order for me to find out like what number I cannot use for x, like I can plug in anything. 1 over 2, 1 over 1, 1 over negative 6, 1 over 12, 1 over negative 3,000, 1 over 17. But what can I not have in the denominator? What's the one rule that I cannot have in the denominator? 0. So here's what I'm going to say. I can use all real numbers. However, x cannot equal 0. This is called a restriction. It's what I can't do. How about here? X minus 8. If I'm not quite sure, I set it equal to 0. I could do any number in there. 7 minus 8, 14 minus 8, 3 minus 8, 0 minus 8. But what can I not have in the denominator? A 0. What minus 8 would equal 0? This is pretty simple. Yeah, it would be 8. I'm going to add 8 to both sides if I really need to like solve it out. So 8 is the number I cannot pick. All real numbers, semicolon, x cannot equal 8. Okay, number 8. I'm going to do 8, but then I'm going to leave 9 and 10 for you to do for homework. All right, number 8. 2 minus x. I cannot have 0 in the denominator. So set the denominator equal to 0. This is a weird one because I have to subtract 2. But Then I need to get rid of the negative sign. So x cannot be 2. All real numbers, however, x cannot equal 2. And you'll need to do 9 and 10 for homework. It's not too hard. All right, let's turn the page. Some of these you're going to have to do for homework also. Okay. This is pretty easy. Given the coordinates, map it, then state the domain and range. I'm going to make you do 11 for homework. But let me start number 12. The domain. We did this earlier. All real numbers. I say negative infinity to positive infinity. It's continuous because it's a line. It's not just dots. And it is a function because it passes the vertical line test and my x's never repeat. Can you like your music? Can you stop? Okay. So you can do 13 for homework. And I'll do 14 on the back. Fourteen is kind of a weird looking one. What's my line? Where is it? It's not at -7. It's not at -6. Oh, it starts where? Where does my line start? -4. Is that an open circle or a closed circle? Closed. I'm going to use a bracket, and I'm going to scan from left to right. I'm going to say -4, -3, -2, -1, 0. It's between -4 and 0. 0 also has a closed circle, so I'm going to put a bracket after 0. This tells me what it's between. You know what also works for between? When I go like this. -4 is less than or equal to x is less than or equal to 0. That's another way to say between. And then it takes a little break. And then I have another little line segment. This is a line segment in geometry. It starts at 2. Bracket because it's a closed circle. And then it goes to 2, 3, 4, 5, 6, comma 6. 6 has a closed circle, so that's a bracket. And if I wanted to use another notation, I would say between like this. I use a less than or equal to because it's a closed circle. If it were an open circle, I would just use less than. This is not continuous. The reason this is not continuous is because it stops and starts. So I'm going to say that this is discrete. And yes, it is a function. 16, I just list where do my dots appear along the x-axis. You can do 15 for homework. All right, let's talk about 16. Where do my dots appear? Scan, not at -7, not at -6. Oh, at -5. I'm going to make a list. So, okay, when I make a list, I'm going to have, this is called a brace, B-R-A-C-E. It looks like this. Have you guys seen this fancy parentheses before? It's hard to draw. You can practice it. Okay. -5. Where else? Not -4, not -3. Does it hit at -2? Yeah. Not -1. Oh, it hits at 0. See how it hits at 0? I'm scanning from left to right. -5, -2, 0, comma 0, comma what? Where else does it appear? 3, and then comma what? 6. Close the brace. This is the hardest part of the brace, closing it. Because you have to do it backwards. This is obviously discrete because it's dots. And is it a function, yes or no? Did any of my x values repeat? Where does it repeat? This -5 is bad news. It's not a function. -5 repeats. Okay, so you have minimal homework finding domain because I'm just introducing it to you very slowly. Let me stop the video.